Hey guys, this is Mr. H. Hey, I want to do a, video on how to determine if a number is rational or irrational. Um, since we're dealing with we're in an Algebra 1 class, the Algebra 1 class does not deal with imaginary numbers. It only deals with real numbers. And real numbers are divided into two major classes, rational numbers versus irrational numbers. So what I'm going to do is I'm going to do a quick definition of what irrational numbers are, and then anything that's not irrational, we'll assume it's rational and it's not in the imaginary bucket. All right, so I'm going to use this one on the screen to kind of show you what. Let me take a picture. Let me make this a little larger. All right, so they're basically saying determine if this number is rational, irrational. Okay, in order for it to be irrational, there has to be two conditions that it meets. One, it has to have a decimal that goes on forever, doesn't terminate. That's one thing. All right, that's supposed to be terminate. And the second thing is it cannot have a repeating pattern. Right. That's the conditions for it to be irrational. Those two things have to be true. And if either one is not true, then the number we assume is rational. Now, a repeating pattern is something like 6, 6, 6, 6, right? Going on forever. Or if you have point 1, 2, 3, 1, 2, 3, 1, 2, 3, going on forever. Supposed to put dot, 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 right? Now, that's what a repeating pattern is. So this one, it goes on forever. So that part is true, and it doesn't have a repeatable pattern. So this one is definitely irrational. So let's go ahead and answer this. So we can go here and we can say this is an irrational number because it it's a decimal that does not terminate or repeat. And then it says nice. Okay, so let's do another one here. This one. Now, the reason that I included this one in the menu 23 list is basically whenever you're given a square root, if the number inside that you're taking the square root of, if it's a perfect square, then the square root of that number is going to be rational. Otherwise, it's going to be irrational. So the reason that I included this in the menu 23 list is that this number, let me take a picture. We have to know, is this number a perfect square? Right? Now, if you know your perfect squares, then you know that 25 is a perfect square, which means when we take the square root of it, it's going to be a rational number. But if you don't know that, then you just grab your calculator. Let me get rid of this, menu 15. And you just type that in, menu 23, and you just type in 25, and you say, oh, that's definitely a perfect square because the exponent is an even integer. So we know it's a perfect square. Now, the other way that we could do it is we could just actually go, what's the square root of 25? And just see what the answer is. And again, you see that the answer is 5. So that's a rational number. So again, two ways to do this. You choose. So this is a perfect square. Let's go ahead and answer this now. So this is a rational number because we're taking the square root of a perfect square. That's what we choose. That's how we do it. Submit it. And it says, nice job. Okay, our next question. Right, is this a rational number? Well, it terminates. So as soon as we see it terminates, then we know it's rational. That's why we can just say the decimal terminates. We don't have to look at whether it's repeating or not. All right, let's do another one. All right, this one. Now, this one is one of the tricky ones, so I want to explore this one a little bit closer. Right. Now, this one definitely goes on forever. So that so far it looks like it might be irrational. And it definitely has a pattern. So it's going 2, 1 and then 2, 1, 1 and then 2, 1, 1, 1 and then 2, 1, 1, 1, right? So you can see it has a pattern, but it's not a repeatable pattern in the sense that if I were trying to write this, and if I put a bar, this means that this is repeatable because this is 21, 21, 21, 21, 21, all the way out. But this one, there's no way for me to indicate like this is a repeating pattern. I can't use a bar because each time the one is going up, been incremented by 1. So this, even though it has a pattern, it's not considered a repeatable pattern. So this would be an irrational number. All right, so let's go and let's say that it's irrational because it doesn't end and it doesn't have a repeatable pattern. And okay, so you just have to be careful. It does have a pattern, but it's not a repeatable pattern. All right, so let's do the last one here. Square root of 81. Now, again, if you're not sure, because all we need to know is this number a perfect square? If it is, then it's rational. If it's not, it's irrational. So that's why we need menu 23. If you're not sure, just put that number in. And if the exponent is an even number, and it is, that means it's a perfect square. And if we take the square root of a perfect square, we always get a rational number. So let's go and finish this. So this is rational because we took the square root of a perfect square. That's all you have to say here. Let's do one. Let's do one more. Is this number a perfect square? 49 is. But again, if you're not sure, do menu 23, type the number in, and look at the exponent. If all the exponents are even, it's a perfect square. Boom, that's as simple as I can make this. So this is a perfect square, which means that when we take the square root of it, it's going to be rational. And that's all we have to say. Let's see. Are there any more interesting ones? Oh yeah. Okay, one more, last one, I promise. Again, this definitely take a picture. This definitely goes on forever. Why can't I write? Yeah, the dot 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 means it has goes on forever, and it does have a pattern. It's nine, then two nines, and three nines, four nines, five nines, right? So it definitely has a pattern, but it's not a repeatable pattern. I can't write it. I can't indicate that it's a repeatable pattern with the bar or anything. So it's not this. So this would be 0.29, 29, 29, dot, dot, dot. This is considered a repeatable pattern. This has a pattern, but it's not repeatable. So we would say this is an irrational number. So this will be the last one. We're going to say it's irrational because it doesn't have a repeatable pattern and it goes on forever where is that? Right here. Submit it. All right, we're done. That's it, guys. Gonna stop and post this.